Welcome back to our Introduction to Pyomo Abstract Models. In this video, we're going to cover adding decision variables and objective functions to our CSL abstract model that we've been working on. So as far as adding decision variables, if we look at our CSL abstract model, we're looking at adding lines of code that represent adding our trainee technician decision variables and our experienced technician decision variables. And so far we've seen that our entire code looks like this, which is probably pretty small in your view, but we're going to look at it in more detail. And we're going to look more closely at these two lines here, which are creating our decision variables. So again, zooming in a little bit, we're focusing on these two lines here that are creating our decision variables. We also need to make use of the sets that we've created. But all these sort of parameters that are between the sets and the decision variable code, we don't need those right now. So in the following views, we're not going to see those parameters, but those are still there. So our formulation for decision variables, we can see the code, or sort of like what we would write on a paper up there. And if we were to code this in Pyomo, it would look something like this, where we've defined our sets previously, and we make use of them in these decision variables. So we're going to talk a little bit more about these details. So looking just at our lines of code that create decision variables, we see that we're using the Pyomo var function again, just like we did in concrete models. And this var function makes decision variable objects. And when we have an abstract model and we want to make a set of decision variables, the very first argument that we pass the var function is a set. So here we're passing our var function our set of months. And that basically tells our var function to make a decision variable for every single one of the months that we put in that set. And following our set for months, we separate our parameters that we're giving this function by commas. And then finally, we see our within parameter again, just like we did in concrete models, where we can specify the range of decision variables. So here our range is once again the non-negative reals. So that's essentially adding non-negativity constraints to our model. Now, towards the end of these tutorials, we're going to see that we're going to be merging our model file with our data file. And when we do that, we'll have something called an instance. And once we have that instance, there's going to be a decision variable called E for every single one of our months. And we'll also have a similar decision variable called T for every single one of our months. So once we make that instance, in the background or available for use are the following 10 decision variables. There's one for every single one of our T element decision variables and one for every single one of our E decision variables. And we can see that we don't really have subscripts available in Python. So to act in the place of subscripts, we're seeing our first use of those square brackets. So if we wanted to access a particular one of these decision variables, we're going to use square brackets. And then inside the square brackets, we would put what month decision variable we would like to use. So if we compare our abstract model decision variable code to our concrete model decision variable code, we can see that it's a lot more succinct. So in particular, it only took us 2 lines of code to create our decision variables. And in our concrete model, those same decision variables were made with 10 lines of code. So our abstract models can be a lot more efficient to write, especially if we're writing really, really large models. So we just took a look at the code needed to create decision variables. Now let's move on and look at using those decision variables and some of our parameters to create our objective function. So we can see our objective function here in our abstract model. It's the min labor cost function. We're going to replicate this in Pyomo. So this is our first look at abstract objective functions. So if we just take a closer look at this objective function formulation, we see that it has quite a lot going on in it. First, we see that there's some parameters being used. We're using the salary EXP and the salary trainee parameters. We're seeing that this objective function makes use of two of our decision variables, the E sub t and the T sub t decision variables. We see that it's using a set to tell our summation function what to sum over. We see that it's using a summation function, so we'll learn about summations in Python. But first, we're going to talk a little bit about how objective functions work in Pyomo, and then also just review in general writing functions in Python. So an objective function in an abstract model in Pyomo has two parts. First, there's a rule, and then there's an objective function declaration. So this rule is essentially a Python function, and the only job of this function is to return an objective function expression. And then our objective function declaration uses the objective function, and it provides the rule that's needed to make the objective function expression. So this may sound confusing, but there's essentially two parts. There's a rule, and then there's another objective function that uses that rule. So we are essentially going to write a rule, and the only thing that that rule will return is this complicated looking expression right there. So before we get into how to write that complicated expression, let's just take a brief review of writing functions in general in Python. Okay, so as we can see here, I have a new file. There's nothing in it. We're going to write some simple functions today. So every single function that you write in Python starts with the keyword def. And you can see that it turns blue. It might turn a different color on your screen, but it should turn a color. So after the word def and a space, I can give my function a name. So I'm going to call mine awesome function. And then after you give it a name, there's sort of these parentheses, and inside these parentheses are where you can specify what's being passed to this function. So I'm going to say what we're passing is a name. And then after my name and the sort of list of arguments, I'm going to put a colon. This colon basically says execute every single line you see after this colon, as long as it's still indented. So what I want this function to do is simply print out a statement. So I'm going to pass it a name, and it's going to print out that name, followed by the phrase is awesome. So this is a very simple function. If I call it and pass it a name, it's going to print out whatever that name that I passed it was, followed by the phrase is awesome. So we could test this out. We could say, we could call it awesome function, and I could pass it the name Dr. Katie. Or I could call the function awesome function and pass it a whole phrase. I could say anybody who likes llamas. And if I were to run this program, we can see over here in the console that it printed out two phrases. One, Dr. Katie is awesome, and then it also printed out anybody who likes llamas is awesome. Now, this is sort of a bizarre use of functions, but it demonstrates a use of functions. Now, not all functions take just one argument. Sometimes we could pass multiple arguments to a function, and it could do something maybe a little bit more useful. So maybe I wanted to define a function that adds numbers. So I'm going to call this function the adder function. And my adder function is going to take in two numbers. I'm going to call them I and j. And when this adder function receives I and j, all I want it to do is return the sum of I and j. So it's going to return I plus j. So outside of this function, if I wanted to use this adder function, maybe I have two numbers I and j, and I want the total of them. I could say total equals adder function, and maybe 1,000 and 57 are my two numbers. And if I wanted to like see this function outside of my code, I might print that total. So if I were to run this program now, first it's going to print off Dr. Katie is awesome, then it's going to print off anybody who likes llamas is awesome, and then it's going to use my adder function to save the total of 1,000 plus 57, and then it's just going to print that total. So if we run this function, we can see my two awesome phrases followed by 1,057. So we're going to be writing a function, and instead of returning I plus j, or instead of returning, or instead of activating a print statement, it's going to return an objective function expression. So let's take a look at what the code to do that looks like. Okay, so again, our rule is going to be a Python function, and all this function is going to do is return this summation expression here for our objective function. So here's the code to do that, and some things I wanted to point out. One, it starts off with the keyword def. Second, I've given it a name. I've called it objective underscore rule. It's a lot easier to keep track of these rules. We're going to be making more of them when we're formulating constraints if we use the convention of underscore rule after each of them, after each of their names. Now, instead of passing my objective function rule a variety of different possible parameters, here the only parameter that ever gets passed to an objective function is a model. So here I'm passing it a model. And you always, always, always must pass a model. And we can see that model that we passed it being referenced several times in this objective function. Now, I'm always passing a model, but I don't necessarily have to call it model. I could have called it something like T-Rex, and then everywhere you see the word model being used, I would have used T-Rex. But this can get kind of confusing, so it's a lot easier to keep track of things if we just pass something called a model, and then reading our document is going to be a lot more straightforward. And then, as always, once we finish our function declaration, we want to put a colon there so that Python knows, all right, everything after this colon is what this function is supposed to do. And all this function does is return an expression for our objective function. So these two lines, on the top we see our objective function expression in like a formulation that we would write on a paper. That is exactly equivalent to what's in the red square below in Python code. So these two are equivalent. Let's take a closer look at them. But before we do that really complicated summation, let's do a more simple summation so we can see the different parts. So a summation in Python starts with the sum function. So instead of that sigma, we write the word sum, all lowercase. And just as we would include parentheses around what we're summing on a piece of paper, we have parentheses around what we're summing in Python as well. And then the very first thing we put inside those parentheses is the expression for what we're summing. So here we're summing x sub t. But of course we don't have subscripts in Python, so we're kind of creating the idea of subscripts with square brackets. And then in the brackets, we write this placeholder t. And then after the expression for what we're summing, we need to put the range. So on our paper, it just says t in months. In Python and Pyomo, we write for t in model.months. So we need to specify what values of t are we going to use. And this for t in model.months goes after our expression that we're summing, but it's still inside the parentheses of the sum function. Now see these values t? T is a placeholder, and the t that we use in the x sub t must match the t in the for t in model.months. Both of those letters must match. But we could have used any letter. So we didn't need to use t, we could have used any letter we wanted to. So we could have used G, that'd be awesome. We could have used K, that would also work. We could have used something longer like the word month. So it might have said X, and then in square brackets month, and then we would say for every month in model.months. But what we can't do is have them be different. So we can't say X sub I, and then for J in model.months. That's just not going to work. So don't do this. So a summation function has three parts. The first part is the word sum. That just says, hey, we're going to sum some stuff up, or kind of like saying we have a sigma sign here. The next part is the expression that we want to sum. And then the last part that's inside the parentheses is the range of values for our chosen placeholder. So going back to our more complicated summation, we see those same parts. So we see our summation corresponds with the word sum. And then we see this kind of complicated expression is represented here as well. So some of the parts you'll notice is that salary.exp. When we wrote that in Pyomo, it's called model.salary.exp. And when we have our salary trainee, it's called model.salary_trainee in our model file. And then additionally, we see the use of our decision variables e sub t. Here we see model e sub t, but the e sub t part is represented by square brackets. And then we see the same for our trainee variable t sub t. We see model.t, and then in square brackets, a little t. Then we see the range that t is supposed to take in the expression, and we also see that in our summation function as well. So we see for t in model.months. So this whole thing here is a function that when it's called, it returns the expression for our objective function. But the curious thing is we personally never write code that calls this function. What we're going to do is provide the name of this function to Pyomo's objective function, and it's going to call this function in the background. So the next part is to write the code that does that. So now we have our rule. Now we're going to write our objective function declaration that's going to make use of that rule. So this is our rule that we just created. And now we're going to add this second line that's part of our creation of an objective function. And this is sort of our objective function declaration. So let's take a closer look at this second line here. The first part we see is we've have this part of the code that says model.laborCost, so we're adding something to our model called labor cost. Here we see we're making use of the objective Pyomo function again. We use the same function in our concrete model, but now instead of explicitly writing the expression, we're going to provide a rule that Pyomo can call to go make the expression. So one of the parameters we're providing this objective function is the rule to use to make the objective function expression. And when we specify the rule, we're basically providing a function name. So here, our function name was called objective rule, so that's what we've provided within this parameter. And then finally, we have the sense parameter, which is the same as it was in a concrete model. It tells our Pyomo objective function whether we want to maximize or minimize. So this is all the code that we've covered so far, and I just wanted to point some things out. We started by making some sets, so our model has one set, it's called model.months, and we've used that in several places so far. We've used it when we made our decision variables. We said make one for every one of our months. And we've also made use of it in our objective function. In the range of our summation, we were able to make use of that set as well. When we made our decision variables, those same decision variables are used in our objective function rule, which is creating sort of our expression for our objective function. And we see that when we need to talk about sort of the fact that there's subscripts, that we use square brackets. And then finally, some of those parameters that we made earlier, we made use of in our objective function expression. And then when we made our objective function rule, we referenced that objective function rule when we made our objective function. So far we have covered creating a model and adding sets and parameters, and we also made a data file. We created our decision variables, and we also have created our objective function. So now we're going to look more closely at how to add abstract constraints.